Okay, so here's the first example for the inductor circuit. We given the inductor circuit, and we given a switch is be open at t equals 0, and they ask to find the I of t. When mentioned about the I of t, that means complete response. That's what that means, even if they don't state it clearly. Another thing, if you don't state it clearly, the state before the switch change situations open to close or close to open, it is stay for a long time. Generally, when you solve the problem like this, we have two things. We're gonna follow the formula. Right now, I have the inductors. So my formula that I try to follow it, this is one, I of t, I short circuit, plus I of 0, plus I short circuit, exponential minus t over tau. Where is tau? It is L over R total. So basically now what we're going to try to find, we find the I-O and I short circuit. Okay, since we have L and we need to the R Thevenin or equivalent to find or to calculate the tau. And I have to start with the initial conditions. Initial condition, the situations before the switch over right now. I can represent it in that case, t less than 0. Or we can do it another way, t of 0 minus. Just immediately before I open the switch. And from that case, I need to find my initial condition, which is I of 0. Okay, so that's what we're gonna do. So let's start with the first part, how to find initial condition. Let's draw our circuit before the open the key or the switch, how it looks like, and we find our current from there. So here is we have the voltage source. We have short circuit here. Since the switch is closed, so that means cancel this resistors. And we have 6 amps here. Another 6 amps in the lower side. And the last part, the inductor circuit or inductor part. Inductor part, since stay for a long time, represent the inductor by short circuit. So here is my current I of 0 that I'm looking for right now. And here is the 6 ohm, and here is the 6 ohm, and here is the 12 volt. What the current I of 0 equal, guys, from the circuit? And just to be clear, we can call it I of 0 minus. How we can find the current right now, guys? Which is the current in this branch. How much?
Would it be 12 volts divided by 6 ohms?
Divide by 12 volt, divide by
6 ohms.
6 ohms. That's correct. This current will be cancelled just because the volt is 0, so I have 2 amps. So that's the first part. We get our first element from our formula. Here from here, you can see here is the second period, where is the t larger than 0, I of 0 plus equal current before the open the switch equal 2 amps. Now we are looking for the short circuit current. Short circuit current, t larger than 0, that means my circuit is open. So I have the circuit now. I draw my circuit again, but this one will be include my another 6 ohm resistors. And again, this one, it should be my I short circuit. Okay, here's the 6 and 6 and 6 amps. And here is 12 volt. How you can find the current right now? I short circuit. An idea, the same way that we did from the previous one, I short circuit. The only difference in that case, again, this part will be negligible. So now instead I have 1.6 ohm, I have 2. So the same formula is 12 volt divided by 12 ohms. And I have here's 1 amps. What is still left? I calculate I short circuit. I have this one. The only thing that I need tau, which is R over R Thevenin, L over the R Thevenin. How much R Thevenin in this case, guys? Open circuit. Look at the side. What you end up with? R Thevenin in that case will be 6 ohm parallel, this one, parallel with those two resistors in series. 6 ohm plus 6 ohm. If you have any question, let me know. So in that case, 6 and 12, so 72 divided by 18. This one for question with that. So once I found my R, so I can calculate my time constant tau, which is L divided by R. My L, it is 8 Henry divided by 4 amps, and I end up with 2 seconds. So now I can write I have all the elements from my, change the color. So let's type it here in the small square. Here is the final formula for my circuit. I have I of t will be equal the I1 plus 2 minus 1 E os minus 0.5 t. So we just simplified here. 2 minus 1 would be, I think I switched it, right? Yeah, I did, no, I did right, yeah. I short circuit 2 and 1, yeah, I did right. So here I end up with 1 plus E os minus 0.5 t. This is one for the t larger than 0. This is my response for my, go ahead.
Are the units for tau seconds? Is that what that is?
Which one?
For tau, is that
yes.
a S?
Yeah, but here is the formula t over tau. So 1 over 2 is 0.5.
Yeah, I got that. I was just wondering about the units.
Second.
Thank you.
I type it here second. Yeah. Question with that? Okay, if we have no question, let's move for second questions here. Kind of a little bit with a challenge, but let's see how we address it. The same thing here. Anytime you're given a circuit or electric circuit has dependent source in it, you have to be careful. Before you start to solve it, you need to think your concept first, how we find everything. So the step is going to be the same. Here I have the inductor, so the formula that I am looking for is still the same. I of t, I short circuit, plus I of 0, plus I short circuit, exponential minus t over tau. Same thing. I'm looking for all those 3 parameters, I short circuit, IO, and tau. So that we started before in the previous example, we do the same thing. Let's see, here's the T0 minus. Where is the switch? Before the 0 minus, it was open. So my circuit should be looks look like this circuit. Here is the resistors, here is second resistor, and here is short circuit for the inductor part. And here is the independent source, but in this case, open circuit. And here is the current that I am trying to find with initial current or initial conditions. So we have 3 ohm, and we have 6 ohm, and we have 12. Give me the value, guys. So it's very obvious. I have just series circuit, which means the I of 0 minus. The current in the inductor don't change suddenly, so I can claim it's gonna be equal 0 plus after the switch is closed, which in this case 12 volt divided by 9 ohms. This one 4/3 amps. Am I right? Question with that? Now the second part, I will ask you to try to do it first, guys. And here is the second case when I am looking for the t larger than 0, and I have 0 positive will be 4/3 amps. I am looking again, short circuit and RT. What we gonna do? Try to find a short circuit. Let's try to find a short circuit. This is our target. A short circuit, which means in that case the switch will be closed. The switch will be closed. We have the circuit like this. So now the only change here, I will be include my dependent source in my circuit. Then here is the voltage source, controlled current to IA, and here is the my IA, and here is the my I short circuit. Three, 6, and here is a 12. Positive, negative. Give me a guess. Want to try it? Okay, let's give you a minute, guys, to think about it, how we find a short circuit. You can use nodal analysis, you can use mesh, you can use any method you think. The only thing, keep it in your mind. This one is the voltage source, guys. Voltage source, not current source. So even it's function of the current, but it's still considered as a voltage source. Can you try it and provide me the answer for a minute? Just pause with the mesh analysis and see if you agree with me or not. I will assume this current here, the same direction of the IA, and I give him the same name, and the second current, the same direction of I short circuit. So now in mesh number 1, I start from here. So here is the 6 I1, positive to negative will be plus 12 volt, and here negative to positive will be minus voltage. Here is the thing, guys, the current between the two meshes here, it's already voltage source. So I don't need to find the equations between I short circuit and IA. So in this case, it's immediately 2 IA. This one is equal 0. Everybody agree with that? So from here, you can find IA. If my calculation is right, it should be minus 3. Here is the minus 12, here is the 4. Yes, it will be minus 3. Question with that?
How do you know IA goes through 6 ohm resistor?
Oh, here is the thing. IA It's supposed to be the current in this one, right? That's already shown in the circuit.
Yeah.
So that's the current comes from that way with the series. There is no node that let the IA divide into more than one branch. This is already in series. So if I ask you the current here, you told me this is the current here. You're gonna go to the source. You're gonna go this way with the same current IA here. There is no node to let that current divided to the different current. It is none. Does that make sense?
Yeah.
Okay. So it is in series. Now we're gonna use the same method, the same way, the same concept for the mesh number 2. What do we have? We have here's the I short circuit, which is the 3 I short circuit. And here's the minus 2IA equals 0. So from here, I can find my I short circuit. How much, guys? I don't calculate it. I have IA minus 3 is minus 2.
Yeah.
Okay, minus 2. Okay, now I help you to find the IO and I short circuit. And now what next? What next?
R Thevenin.
Okay, how we can find it?
Open the circuit.
Okay, why? Open the circuit to mean this part. And then what next after we open it?
Then we have to find the equivalent resistance.
Yeah, that's what I expected. Anyone has any different option? So this is the guys that's if I go with your path, let's go with your path and see how you stuck. So better than to give you just the answer. Okay, let's go to your path. So here is our circuit. So when we deal the northern equivalent or the Thevenin equivalent, the source should be short circuit for the current source, open circuit for voltage source. So 12 will be short circuit. Then I have here the resistors 3 or 6. Then I have here my independent source. Then I have, what else? I have something else. You have 3 amps. Okay, here's I have 3 amp. So according for your case, that the case I will do it, if I'm right. This is the open circuit you're talking about, correct?
Yeah.
Okay, now how we find our R Thevenin? What do you think? What do you think? I give you your options and give me your answer. How you find right now, R Thevenin? Anyone can help him? Okay, guys, here's the thing. I told you when we have dependent source, sorry, in my circuit, I have to stop and think before I just memorize the steps. Here's the R Thevenin. We cannot delete the dependent source. So R Thevenin, it should be found by V open circuit divided by I short circuit. There is no way to find R Thevenin beside that. When you have dependent source in your circuit, keep it in your mind. So right now, that's the only thing I want to do. This is I'm looking for to find my R Thevenin equivalent. So how much the value of this one? 3 This one 6. Correct me if I'm right, if I'm wrong, guys, please.
Yeah.
12 volt, and here is the plus and negative. Now I have the circuit. How I can find my V open circuit? You can, or we still need some help? I have basically what do we have? The voltage VO is equal to IA, right? Because no current comes in the 3 ohms. So basically, if I find my IA and times by 2, this to give me the voltage across open circuit. What I have, basically I have this bat. That's the only bat I have it, right? Only one circuit and just 2 sources. I can use Kirchhoff voltage law in the directions you want. We're gonna go this way since IA here, just to avoid the negative sign to then replace to the positive side. I will go the same path for the IA. IA here, the first one, negative to positive, will be minus 2 IA. Comes from here, will be plus 6 IA. Give me break. IA, and here plus 2 negative plus 12. This one is equal to 0. How much we get the IA?
-3.
-3 amps. This is my IA. I am looking for the V open circuit. V open circuit will be 2IA, which in this case, 2 times -3. Which will be -6 volt, guys. Everybody still doubt about something. Now, if you get this one, now I can find my RT, which will be -6 divide I short circuit. How much we find it? 2 minus 2, -2 amps. And this one, it will be 3 ohms. Look at the case, guys. Again, when we discussed the stability, we mentioned if I have dependent source or op amps, if my R less than 0, which means negative sign, that my circuit is unstable. Right now, in this circuit, because I found I open circuit and I short circuit, both of them, they are negative, and the end to the R Thevenin to the B positive. So that means my circuit is stable. I have stable circuit. So now you have a sense. Sometimes we end up with the negative R in a case if I find R Thevenin in any way, and you find this is value could be a negative. That means my R's would be negative. If you end up with these situations, there is no real life negative resistance. The only indication for that, your circuit, it is unstable. Question with that, guys? No question? Move on. Okay, sounds good. Let's see this one. I added this one in your, you don't find in your slide, just I added in the last minute because in the homework you will find similar to this. So when I have op amps, how I can deal with my circuit. I'm going to take a minute. The procedure is the same. Just you need to think what the basic definition for the idle op amps and how I can represent it, guys. Okay, now they're asking for the voltage across the capacitor with the certain with the f of t. So again, the formula that we're gonna use, we use the f of t equal v open circuit plus initial condition for the voltage plus v open circuit and E is minus T over tau. Where is tau? It will be R Thevenin times C. You want to take a minute to think about it? So our mission, guys, here, the equivalent part is very important. We are looking for the voltage here. If I found it, then I can finish my resistor, my circuit. Let's think about it, guys, for a minute. Just 1 minute before we started to solve it together. You see my slide, guys?
Yeah, we can see it.
You can see it. I try to open the conversation option from the Zoom to start recording, but it stuck with my case here. Stuck with the computer's bad situations. Let's see. I don't know how I can open it again. Okay, let's see what do we have. What you end up with. Anyone here get something? So here is the thing. In that circuit here, what I am looking for from the entire circuit here. So when I'm talking about the R and C circuit, we are looking for the representation for my circuit in a way. I have voltage source, I have a resistors, and I have capacitors. This is my formula that I formulate in that situations here. Okay. Since this circuit is apart from the other circuit, so if using all the other elements in my circuit, I end up with the voltage in this point in particular. I find this point voltage. That's exactly what I am looking for from the entire part in the left side of my capacitor. So basically, we are looking for, here is what we call it in this case, V open circuit or whatever name you want to call it. Okay, so let's see, we're gonna use the same concept before t equal 0 minus and after. The switch, it used to be closed, right? So what do we have? How much voltage I have? VO at T minus. How much voltage we have, guys? This one's a close using the property of the ideal op amps. The current 0, the voltage V1 equal V2. So I have this one 5 volt. So this one V1 and this one V2, and they are equal, right? So this one equal 5. Right now I have short circuit. So it means this one is equal 5. That means this one equal 5. So I end up with the 5 volt as the initial conditions. That's apply for the capacitors. Question with that. Now for the T larger than 0, still I have O0 plus will be 5 volt. And the circuit that I do have, now I have regular circuit. And I'm looking for the voltage in that point here. How we can find it, guys? This I just try to avoid the drawing, but let's draw it. So right now, this one is open. And this one go to this path with the resistors to the ground. And this one go to the voltage source. And this is when my voltage that I am looking for, open circuit. This one be open circuit in that case. Minus positive. And here is the plus 5 volt. And here's the 20K. Here is the another 20K. And that's it. First of all, guys, what you expected is going to be inverting or non-inverting voltage across this point. What to expect, inverting or non-inverting? Inverting or non-inverting, we are looking for our voltage source where it's connected. If the connected to the non-inverting, that means non-inverting output. If it's connected to the negative terminals, will be inverting output. So here we connected our 5 volt to the positive terminals, means our output will be positive, non-inverting. Now the way how we get it, you can use the op-amp ideal operations op-amp properties. There is no current comes this way. The voltage in 2 bar, they are equal. Here is the 0, and here is the 5 volt. You can use voltage node, the same current. So this part, 5 minus VO divided by 20 plus 5 divided by 20K equals 0. And you end up with the one single variable. It is V open circuit. Anyone who use that method? Peter, do you have something?
Not yet.
Professor,
Justin, yes.
the VO minus equal 5 volts. What is that referring to? Is that the, like, where is that?
Oh, okay.
Like,
Let's see. Maybe I do it in very quick way, but if you draw your circuit or the op amps, but with the switch is closed, so what do you end up with your circuit? How it looks like? I have op amps. I have op amp minus positive, and I have this one short circuit. So I have this one connected here, right? And then I have this one connected to the 5 volt,
right.
right?
Right.
And I have this one here, resistors. That's the circuit that we have, correct? So
Yeah.
here's the 5 volt. Here's the 5 volt. short circuit here means this one 5
Okay.
volt too.
Okay, that makes sense.
Yeah, because talking about the open circuit. So here's the V open circuit or the V of 0.
Okay.
Got
Thank
it
you.
now?
Yeah, thank you.
Okay, yes. Now, anyone find my I open circuit? Let's try to figure how to hit the zoom again to my history recording for the Susan. That is not showing up. Okay, anyone here get the number? Is that hard? Guys, it's 5 volts. 5 minus V open circuit. V open circuit divided by 20K plus, what do we have? 5 volt divided by 20K. This one equals 0.
I did that and got 10 volts, but I was just confused because it wasn't
Yeah,
negative.
that's it. So it's 10 volt is obvious. So it's 20 constant 20.
Yeah.
So we have here is the V open circuit equal 10 volt. You're right. Why you didn't say it? So now basically what do we have right now? I am done. So I have 10 volt. I have resistors. I have the capacitors. Here is the resistors 20K. Here is the 4 micro. And here is the 10 volt. Now I can calculate my tau, which R times C. I have it is R is 20K times 4 power to the minus 6 farad. And how much this value? Once you find this value, I can write my tau voltage equal will be V open circuit will be 10 plus open circuit will be 5 minus 10 E us minus. Anyone who calculate to me the RC? This is minus 6. Here is the minus 3. 80 minus 3, 80 milli. 80 milli, so we can say, correct me if I'm wrong, 8 seconds.
Yeah, that's right.
That's right, okay. So here is the, can I reverse this value? How much you get?
12.5.
Okay, divided by 0.08. And here is the final formula will be, I can say 5 times 2 minus, I don't have to do this way. Let's do it as it is. Here is the 10 minus 5 E os minus, you told me 1.5 minus 1.5 T.
12.5.
No, I mean 1.08, reverse it.
Yeah, so 1 over that?
Yeah, 1 over 0.08, how much?
12.5.
12.5. And it should be a negative sign. So this is our final voltage in the capacitor in that circuit. Again, any circuit that has operation amplifier, it is easy to make solution for it. So the op amps here give me more flexibility. Easy to solve it. It's not that hard to find it. Okay, I don't have to struggle with the Thevenin, Nortons, or whatever issue that we may have. Because sometimes that's what we, again, but maybe it doesn't work with that case. And sometimes you end up with the unstable case for the op amps too. Question with that? Do you still have time? I don't have time in my computer. I didn't see it. How much time we have?
8 minutes.
8 minutes.
8 minutes. Okay, so let's divide 4 by 4. 4 for you and 4 for me. Try this one. This one is a straightforward application for stable or unstable. If you look at this one, the circuit here, it is similar to the circuit that we solved it previously when we have dependent source. So we're gonna use the same approach. Just we need to find those value I open circuit, V open circuit, and I short circuit to find it. Again, so we're gonna give you a couple minutes to find it. Here is the capacitor. Me and I am talking about the voltage, V of T. It will be V open circuit plus 0, V of 0 plus, oh, sorry, not plus, yes, plus V open circuit exponential T minus D divided by tau. And where is the tau again? Equal R Thevenin C. And R Thevenin, just to let you know before we start, this one should be V open circuit divided by I short circuit. T less than 0. What do we have in that case? I start with the initial condition, then I let you finish the second part just to make it less than 0. I have the switch supposed to be open, right? So it's open. So basically, what do we have? We have 12 volt. I have the resistors. And I have current source. Yeah, it's open circuit. That's the only thing we have. So here's the V of 0 in that case. Here's I have 2I. 2I of T. And here is my I of T. Here's the 5 amps. And here's the I of T. And here's the 12. I'm looking for the VO right now. I cannot send you even for the group right now because the Zoom, it is, I cannot open it to send you to the sharing us. So now let's see, think about this one, find I short circuit and V open circuit in that case. And just be careful with that, guys. And then we move for the second part when you connect your circuit to find the I short circuit after the switch is closed. think what we're still missing here that chapter. You want to get the V open circuit, how much is this? V, no, V open circuit, I mean V0. Eric?
I'm getting 6, but I think that's wrong.
Okay, how we get 6? Based on what?
So I did like KCL on the node to get the I of t, but it's not in terms of it's not in terms of time, so I think that's wrong.
Okay. See what else. Try to just be logically, so you don't have to do something else just to find the values. This is what I am thinking about this case, guys. Oh, okay. Now what we end up here, look at what we have something, it is kinds of contradictions. Look what we have. We have right now the circuit, a series circuit. Am I right? Series circuit, correct? In a series circuit, since this one is open, there is no such current go this path. So if we want to use the, oh, I don't know, this one is the I of t and this one 2I of t. How it's work? You can do it in that way. The current, this one comes in, the current, this one comes out. This is Kirk flow. I don't do anything else, right? And there is no current here is equal 0, right? Is that right? So when I have the I of t, if I write down the mathematical equations, I of t, this one's minus I of t comes in and plus 2I of t equals 0. Look at this one here. Adding two numbers, they are equal 0. Mathematically, it doesn't go through right this way, right? There is no way to add a number, then double it. They're gonna give you 0, except one exception. What that exception is? Except what do you think? I don't nothing except Kirchhoff law. And according for the circuit that I have here is the current, and I have here is the current. And they should be, they have the same, that's what we're learning. In series connections, the current should be the same. And I have this one's the I one, and this one's 2I. So in that case, there is no such thing satisfy this formula that I have learned, except if the current equals 0. That's true. So in that case, this equations will be valid.
Professor,
Go ahead.
why can't we do 12 divided by 5 for the current going in to the node?
Okay, let's see, think about it. You said, what the voltage here? How do you find the current across what? You say 12 divided by 5?
Yeah.
What? Here is the thing, you don't have just one single voltage source. This is current, it is already source as well. So it already has a current, his own current.
Okay.
So when you apply this one, logically, if you find the current, if you find the way that you said, you have to assume I have here is the voltage. I don't know what that voltage is. Then I can find the current here, VA minus 12 divided by 5. But I cannot assume This one could be just 12 divided by 5, give me the current through this one. To find the current, you have to know the voltage across your resistance. I have one terminal here, but I don't know how much this one. I cannot claim it is 12 because I have current source here. Are you okay with that? It's confusing a little bit, but just it is makes sense. There is no such, I have to modify my knowledge or what I have learned to solve my problem. That's what I have learned, nothing else. So what does that mean when I have the current goes, this part is equal 0? What does that mean? Regarding for the voltage.
0.
Oh, wait a minute. Anytime talking about the current equals 0, mean open circuit. Am I right?
Yeah.
Am I right? So I have open circuit. Open circuit. So what that mean? Okay. Forget about the initial conditions. We have a 0 right now. Now, just for the sake of time, what the next step? We need short circuit. We need V open circuit. Let's go with the short circuit first. If we over time, let me know, guys. At least we give you one thing to do it and give you extra point to solve it if you want it. Here is the 12, and here is the resistors, and here's our current right now. But right now, I have a resistors connected in this branch. Okay. You want to find I short circuit or open circuit? Let's find open circuit, easy to be open circuit here right now. Here is the 10, and here is the 2I, and here is the 5, and here is the current, our I of t. Again, what we're gonna find, guys? We look at the voltage across the 10K. I will assume this case. If I have this current here, this is I. If I found it, then just multiply by 10K, give me the voltage, right? So I have the current go this branch, and I have the current go this branch, right? What is the new here, guys? I cannot assume this one is equal to 0 because I have here the resistance. They have the current right now. I have the current go this way. You can, this current here, the I minus I plus 2I equal what? If you write down the same equations now, minus I of t plus 2I of t, 2I of t plus I now is equal to 0. So basically I have, here is the I from this equations here, I equal minus I of t. Now how we find that I can use nodal analysis for the current. Here, what do we have? I have VO, right? All the voltage here the same, so this is VO. So VO minus 12 divided by 5. This is IA. Oh, sorry, the I. And here's plus V. I don't have to say VO. Oh, I don't know this one because I have the current here, guys. So basically what I will say VO minus 12 divided by 5K because they are current plus 2I of t plus VO divided by 10K. This one is equal to 0. Can we find VO from here? Or can we find I? So either way. So I have the I here. Again, what the I of t? It's basically VO minus 12 divided by 5. So I can replace it here. I can replace it in this part here. So we end up with the equation with the VO only. And then you can find your V open circuit from this one. I feel it's quite confusing, guys. So I promise I'm not gonna give you an example like that.
Professor,
Go ahead.
instead of the VO over 10K, couldn't we just write negative IT because that's the current going out?
Which part?
Where you have VO over 10 kiloohms?
Yes.
Isn't that the same as just I, which is negative I of t?
Yes. It is the same.
Okay.
It is the same, yes. Because this part, basically, this one is the I. This one is the I. Where's the my pen? This one is the I, this one. What's the time now? We are over time.
Yeah, we're 10 over.
Wow, sorry guys. I really apologize. I told you let me know. But I'm feeling good. We solved 3 problem and we end up with this one. So I will solve it this one here and post it. So you can look at it in the post slide, guys. Sorry about that to let you stay for 10 minutes over. Okay, I will clean it over and I will solve it again.
Thank you.
You have any question, guys?
Have a good day, Professor.
Same to you. Have enjoy your weekend.
You too.
Thank you. Professor, could I get a resubmission for the lab 7? I submitted it yesterday and I realized I had a typo.
Okay, I will try to give you an option to submit more than one submission, but I don't know if it's gonna work or not. It's gonna try it.
Okay.
Let's try it now. That's
And also, I think I realized why the oscilloscope wasn't working yesterday. It's because I was using a 10 microfarad.
I told you, ask you, did you confirm the resistance capacity? You told me yes.
It's because we didn't have the other 0.1. They were being used, and I thought there was a point where we used the 10 micro one, so I thought that was the part we had to do.
But it's good to know. Okay, I know what to figure it out. Something I did mistake. So
yeah,
better than something goes wrong, but I don't figure it out what.
And then on the lab report, I said I used the 10, but then I was thinking about it after I submitted, and I was like, oh wait, I switched it with Justin again. So I actually used the 0.1.
I good with that. I give you an option to submit it more one submission. So I don't know. I hope it's gonna work. You can try to refresh your page and try.
I can check real quick.
Yeah.
Yeah, I can resubmit. Thank you.
Yes, I opened for you some multi submissions. Yeah.
Thank you. Have a good weekend.
Same to you.